drop it right in the center of this bridge and then walk around in circles, much like our lock attendants did in the last lockage. It would take them about 15 or 20 minutes to open and close this bridge each way. Nowadays they use a 5-horse electric engine, which does basically the same task for them. It does do it a little bit quicker for them, however. They can open and close this bridge in about 5 or 6 minutes time now. But I'll give you all a quick explanation about how this works. When we pull into the chamber, I will explain it just a little bit better. One chamber we should be able to all see now, way up in the air over on the left-hand side, and its large cylinder stretching out beneath it. The secondary chamber is in its lower position over on the right-hand side. Its large gate has already opened up, as we do have a green light to enter the chamber. We will now pass directly over top of that gate, and they will close the gate behind us. Then the lockmaster, way up in the tower, is going to push a button that opens up the crossover valve. Then that chamber way up in the air is going to come down, making the chamber on the ground rise up 65 feet or 19.8 meters. When they first started building this structure back in 1896, they estimated taking only 6 years alone to build this giant structure to excavate some 27,000 cubic meters of material inside of this large hill. They then planned to pour in an additional 25,000 cubic meters of concrete, making this at that time, of course, the world's largest concrete structure. The total estimated cost of building this back then, $350,000. Although working conditions were rather harsh back then, it did take them a little over 8 years to build this structure. They did top off a little over $550,000, but that was the first and only time the federal government ever went over budget. Well, maybe not the only time. Yeah. I don't understand what you mean. I can't quite hear you. Yeah. It is. It's just the gate's open right here. Well, it's like, think about it. It's like being a giant bathtub. Drive in into a big bathtub. Into the air. Now it's gonna, I guess it's not quite that fast. The last lock took us about 10 minutes, rise 4 meters or 12 feet. This one's gonna do 65 feet in about 2 minutes. So it's much faster than the other lock. Now we do start very slowly at first, just let the rubber seals at the front and back of these chambers slide apart. But the crossover valve is gonna about to kick into about a 75% capacity. We're gonna move much faster. And away we go. Now this is still the world's highest hydraulic lift locks, ladies and gentlemen, two of which are in North America, one which is in Kirkfield, a little further up our Berry system, but this one is still the highest at 65 feet or 19.8 meters. Now I will remind you all one more time, it is a single foot of water inside this chamber coming down beside us right now that's making this all work. After they open up the crossover valve, gravity does everything else. So it's kind of like a giant teeter-totter, a seesaw, let's say. Of course, an amazing feature about this is we can move both traffic simultaneously at the same time, both directions, 1 foot of water. But there's no boats in the other chamber. Not that it makes any difference at all. We can have 50 boats in our chamber and just 1 in the other one. Every boat displaces its own weight in water, so whichever chamber has the extra foot of water also has its extra 130 tons. As we do continue to rise, ladies and gentlemen, don't worry about that little bit of shaking we may feel from time to time. Remember, the structure just turned 108. Well, you would shake too if you were 108 years old. I have friends that shake and they're 25. Let's say we have a little bit of time, I can tell you about that little mishap. Back in 1990, they used to, or even not even up until not that long ago, they still do it from time to time. There's no rule or regulation saying they can't, they just normally don't. But they used to load all the time both chambers simultaneously. So they'd have the lower gate open and the upper gate open, and both going into it at the same time. Well, on this day in 1990, they were doing just that. The lockmaster, who was way up here in the tower, was watching the lower chamber as boats came in. Sometimes, when boats come in and out of these chambers, they have to add or release pressure to the large cylinders beneath them to keep the gates aligned. Well, on this day, the lockmaster was watching the lower one and adjusting it accordingly. The only downfall is he was adjusting the wrong chamber. He thought he was adjusting the lower chamber when in fact he was adjusting the top chamber. What that did, wrecked the rubber seal all the way around the upper gate, ripped one of the hinges off, and this entire upper canal drained into the lower canal. So they don't do that. Who built and designed all of this, Mr. R.B. Rogers, or Mr. Richard Birdsall Rogers, was born right here in Peterborough. He went to Trinity College at Port Hope. He later went to McGill University in Montreal, where he did earn his engineering degree. When he was first hired as chief engineer of the waterway to overcome that 77-foot elevation change, his first major thought was to put in giant flood locks in beside every existing hydro-generating dam and plant on the riverside of all this. But in order to do so, he would have had to shut down the river, shutting down mill and industries for months, if not years at a time. So this, as we go a little bit closer, two red lights indicating we're not allowed into the chamber as of right yet. On the left is going to turn green here any moment as the gate hits its lowest position. You may also be able to notice the arrow light indicating which side of the chamber we should go to. If we were to go off the other side, we'd get down just a little bit quicker. We're not going to do that today. Now that we have a green light into the chamber, when we go by this concrete doorway, look in through the tinted glass windows on our right hand. that we have all safely and successfully traveled to Peterborough Lift Locks, I would like to tell you all about the 2 minor accidents we had when the back gate fell open halfway to the top. We didn't call these accidents minor because, well, we weren't here that day. When they first began operating these locks back in the early 1900s, it operated much as it did now today, with one single employee down on the lower chamber, putting in and taking out those fluorescent manual locking pins to the empty chamber. It was at this point, though, that the federal government decided to send in several engineers. They dismantled a good portion of the lift lock and did a thorough investigation. It was at the end of this investigation that they determined that it was not human error that was causing all of these problems. No, in fact, it was mechanical failure. So in turn, they decided to bring back those manual locking pins and the employee to put them in and out every time, and they will not run the locks without them. Now, I do talk to these lock attendants and lock masters on a daily basis. You know what they tell me? That this would possibly, may never ever likely, could ever happen again, they think. We get into our own dock, hopefully we won't lose anybody down between the boat, the dock, and into the drink. Thank you very much, everyone.